Ladies and gentlemen, my name is Alessandro. It's a pleasure to speak to you. I'm the co-founder and CEO of Microcaps, and what we're doing at Microcaps is microcapsulation with Swiss precision. So we bring the new gold standard to the market of microencapsulation. So we're always working with the following benefits in our system. It's about controlled release of active components, such as an API, microorganisms, or an anti-aging compound. We're talking about protection of the active component. For example, if you take probiotics against the acidic environment and then have a release in the intestine. We speak about shelf life extension by protection of the active with the matrix of the capsule. We speak about targeted delivery, can be either a pH release or a mechanical release that you have, also temperature release of your capsule. And many companies come to us with the request for patent extension by reformulating their active component, having different release profile, you can reformulate your compounds. And we bring all these benefits towards the industries of pharmaceutics, cosmetics, and food. And further on, a mix between food and pharmaceutics to the probiotics market. So if you look at today's problem, if you're using microencapsulation, you mostly either use spray dryer or batch processes, which end up with a very poor size control over your capsule and a very poor size distribution of your system. Plus, with the high shear forces that you add in there, this might damage your active that you have inside. Examples, bacteria, proteins, complex API, this all gets very problematic and you might end up with a huge loss already during production. Furthermore, you have most of the time poor efficiency. This comes from two main reasons. First, during the encapsulation with the high shear force, your active tend to leak out into the continuous phase. And second, you may introduce filtering processes afterwards if you want to have some sort of size control, and you end up throwing away a lot of your actually produced capsules. Also, due to the very uncontrolled sizes, you might not have perfect control over the dosing that you have in there. And this could be overcome by microfluidic system where you can actually control all these systems. The problem today is that the current systems that are on the market have a very limited throughput. Thus, you will never bring this towards industrialization. And that's exactly what we're changing in Microcaps. We developed a system based on continuous flow microfluidics that can be upscaled towards industrial standards. So based on this continuous flow, we can actually shape and tailor the structure of the capsule size, of the capsule shape, and of the structure that you have of the inside your formulation. And we can work with this with emulsions, with capsules, and with microparticles. Very importantly, our system works stress-free for both the operator that is using it, but way more important, stress-free in terms of encapsulation efficiency. So no shear force, no chemical or heat stress that you have during your production, which allows you to encapsulate with the highest efficiency bacteria, proteins, and complex APIs. Due to this high encapsulation efficiency, so typically we're with numbers in 90% of higher encapsulation, we have no need for size selection afterwards, and really all your active ends up in the microcapsule. Furthermore, because all capsules have exactly the same size, you know exactly what is in your system, so you have a very precise dosing. And now again, compared to current microfluidic methods, we scale this up by a factor of 1,000. So at the moment, we're producing capsules at a rate of 100 kilograms per day. And this brings various benefits towards the market of drug delivery, aroma, taste masking, probiotics, or cosmetics. Actually, why can we do this? Because we introduced to you the EOS system. This is microencapsulation controlled at industrial scales. So we developed this precision encapsulation platform, which is based on continuous flow microfluidics. It's very important that we can exchange the microfluidic chip, which is inside, to bring actually a range of capsules from 40 micrometers up to 2 millimeters. And our chip is highly reproducible and parallelizable. So we have up to 100,000 junctions in one chip that I can hold in my hand. And actually, I'm showing to you now how such a device is working. You have this chip down here, surrounded by the continuous phase, and you will see now a swirl from the continuous phase coming out of these holes that actually takes up the droplets, the dispersed phase that is produced down here in the chip, collects them and brings them towards an outlet into a post-process. Now also, very interestingly, we recently introduced a temperature heatable system, so we can heat up our dispersed phase up to 120 degrees, which enables now for the first time in our system to produce either wax particles or hydrogenated oils, everything which can be molten up and then thermally quenched afterwards. Apart from this, we're always working at room temperature, so we have really no shear, no heat, nor chemical stress in our system. The actual chip then is controlled with our control unit that you see below. So the entire system is designed for CGMP compliance, and it's really a pressure over liquid system. So we have a very smooth pressure which delivers the continuous and the dispersed phase towards the reaction modules and enables no pressure peaks, so very smooth and controlled production. The size of this EOS system is of the size of a coffee mug, so you can easily start now parallelizing those reaction modules. And by having already 10 in parallel, we will be able to reach a production of 250 tons per year, which is a throughput of 1 ton per day. And this will come out by mid-21. At the moment, we have 5 of these systems working in our laboratory. So already now we can get a throughput of 500 kilograms per day. So actually, why can we do this? This is actually a real-time image of how we're producing the capsules. So you see a massive production of very size-controlled capsules. This is all real-time, so no time-lapse or anything in there. This is how we're producing. And if you look at them under the microscope, you see, and we're always very proud of having a coefficient of variation of below 5%. If you take the best method on the market, state of the art, you're at 25%. Most of the time you're even higher. So this is if you take spray dryers or batch processes, you end up mostly at 40, 45, 50%. Microcaps always below 5%. Why can we actually do this? Why can we scale up this microfluidic methods? This is based on 5 years of research at ETH Zurich, which was now transferred to Microcaps. It's based on step emulsification. Very important for step emulsification is that the size of the capsule is independent of the flow rates that you apply. So you take one chip, it gives you one size. Even if you have any fouling in the chip, this won't affect anything in your capsule production. I'm showing you here on top how we're producing. You see the crystallinity arrangement of the capsules, so you know they're perfectly monodispersed. This is actually a production of our device that comes top down, so for PLGA production. These are actually the nozzles that you see that produce one by one the droplets and the capsules. So again, we have in our system up to 100,000 parallelized of these microchannels. So this then allows us really to bring the 1 ton per day production by mid-21, at the moment 100 kilograms per day. Very important, our system is designed to have highest chemical compatibility. So the materials that we're using are glass or quartz, stainless steel or Hastelloy, and the connections are all PTFE. As I said before, very robust system. So if you have fouling, what you always start to have, depending on the system that you have sooner or later, this won't change anything in the production. If you have fouling and clogging of the channels, it simply will stop and will not affect its neighboring channels. I show you this here, a massively deslowed production of capsules, and you see here in the front, at the end of the nozzle, you see some first sort of fouling, so you have particles there. Nevertheless, the size that you have that these nozzles are producing are still very monodispersed, very size controlled, and this is the excellent system. So we can really run it over a long term of period. We can walk away. The capsule size will still always be the same, and this is the huge difference towards compared to conventional microfluidic system that you can actually start scaling this up. It's also really designed for minimal maintenance. So you can run it, you can walk away, overnight production. It's not a problem. You come back, the device is still running. Also, compared to standard processes, batch processes, you end up with very reduced solvent use. So typically, continuous to dispersed flow rates are at ratio of 1:1. Usually, droplet to continuous in batch processes is at 1:50. So you get a massive reduction of solvent that you're actually using in your system. So having then this platform, a key benefit of Microcap system is to run different types of formulation on our EOS system. I give you 3 examples of releases that we're having. We have microbeads ending up in sponge-like release. We have multi-core capsules ending up with multiple burst release, and single-core capsules with a single burst release. Starting with the microbeads on the left-hand side. This is a sponge-like release. So typical system are PLGA, PCL, or PEG, so the biodegradable polymer system, where you have an active inside and you have a sponge-like release of these compounds. You can go to the hydrogel systems, so alginate, agarose, hyaluronic acid. You can work with polyacrylamide, polystyrene, DVB, or with the system that I introduced you before with the heating, hydrogenated oils, waxes, for example, carnauba wax. Here always a sponge-like release. You have a solid matrix type capsule with your active inside. Coming to the multi-core release in the middle, this is a multiple burst release. So you have introduced in your matrix, you have tiny droplets of 1 to 5 micrometer in size. So you emulsify a pre-emulsion through our EOS system. There you can have PLGA system with aqueous cores inside. You can have alginate system with oil cores inside. Hydrogenated oils with water droplets inside. This is mostly for the release of compounds that are soluble inside a phase. So you can go to CBD release. You can go through any type of active that you want to have inside your capsule with a multiple burst release. And if you take many of these capsules, you can get really a very smooth and controlled release profile, a bit depending on the capsule size, but you can really adjust. This. If we look at the single core capsule release, this is a single burst release. So you have an oil core with a shell, with a shell around, a solid shell. We're very proud there to be able to do the alginate shell oil core system. So we're producing an oil droplet and then growing an alginate shell on top of this. This is mostly used for probiotic delivery. So you have the probiotics inside the oil. It's always moisture free. They never see any water, but are protected with a solid shell. You can go this system to do this with PLGA and an aqueous core, or a wax shell with an aqueous core. There always you have a single burst. You mechanically destroy the capsule. You have a burst release of your active compound. This is actually a video showing how the EOS is working. I'm very proud to introduce to you Julia. She's our head of formulation. This is in our laboratory, and I let her speak how the EOS system works.
Hi, I'm Julia, and I'm currently producing capsules for a customer. And this is basically our device. This is the control panel where you can set all the pressure and flow rates for the production. And here you can see our reactor. Everything is connected to our phase supplies. And this is our dispersed phase here. This is our continuous phase, both controlled by our control system. And yeah, here you can see how we're emulsifying.
So this is an actual production that we were running for a customer with the alginate shell oil core system. You saw behind the pressure control where you can, with a touchscreen, control the flow rates and control over the pressure system coming into the EOS core part, which is the reaction module that you see in here. You see the massive production that you have inside. Continuous phase to dispersed phase ratio is about 1:1. And with this, we were producing kilogram samples. Actually, this was just a week ago when Julia was producing these capsules for a customer. So I give you very specific examples of formulations that we were producing actually for customers. So controlled release formulations, mostly with PLGA, PEG, or PCL. Most of the time it's PLGA. The system is based with a solvent, mostly dichloromethane, with the PLGA dissolved and the API. You emulsify this in water, you extract the solvent, and you end up with very controlled PLGA particles. You actually see in the background of this slide, you see a production of these PLGA particles for a customer. It's always about biodegradable solid particles that have a very precise release, most of the time for injectables or also respiratory or ocular applications. Again, very stress-free emulsification, so you can actually really encapsulate all sort of APIs from small molecules to complex formulation, complex structures, proteins, large molecules, microorganisms, so on and so forth. We can also encapsulate solids. So this example that I show you on the right-hand side is where we encapsulated solid particles which are magnetic. So you can see coming with a magnet, they move from one side. This is really just a proof of concept that we can do this. Most of the time, this is required when you need to introduce a water-based solid inside an oil-based system, or vice versa. If you were to use standard processes in batch or spray drying, they would all go to the continuous phase, and you have a very poor encapsulation efficiency. With us, 90% end up actually in your capsule, and you have the highest efficiency. You can move this not only for these magnetic particles that I show you, but you can go to radioactive isotopes, for example, or bacteria encapsulation. So encapsulation of solid is not really a problem. Third example, functional coatings. So you can actually coat your capsules. We're using this a lot for intestinal delivery. So we have a coating that is designed to protect at pH 2 in the acidic environment and then release at pH 7 in the intestine. You can add mucoadhesive coating. To show you the picture on the right-hand side where we actually coated our capsule, and then had an ex vivo study on an intestinal pig where we actually flushed for 2 hours with a solution, and with the coating we have 80% of the 2 hours still stuck there, whereas if we have no coating we end up with 0%. Really, we can introduce many different coatings on top of our capsules. That's all possible. For example, on hydrogel solutions, on wax solution, but also on the biodegradable polymer solution. And that's also another problem to do there. How do we work at Microcaps? We are a solution provider. So we really want to bring a customer from the formulation of the capsule towards the production. It's usually 3 phases. So the first phase is a feasibility test, where we jointly develop the capsule and until we have a formulation freeze on our system. The second is a scale up, where we actually use the EOS system and we start to scale up towards a kilogram production, still done at Microcap side. And the third is then actually a know-how transfer and a production. This can either be at the customer side or together with a CMO that we're working with. So usually if you want to have a development program, you start with the proof of principle, you have then process optimization and scale up. You do the first in vivo testing, so either you produce the capsule yourself at your facility or together with a CMO. And then step 4 is actually the production, where we install and training. We do a lot of technical support, technical know-how from Microcaps, and we have a continuous supply of the microfluidic chip in order to enable the perfect production at your site. That's it from my side. Thank you very much for your attention. We are Microcaps, and we really bring the Swiss precision to the world of microencapsulation. And I'm very looking forward to either answer your question right now, or you shoot me an email. You see my email address below, or you give me a call, and I'm very looking forward to discuss your project together with you. Thank you very much.